For hundreds of thousands of years they ruled Europe, thriving in landscapes that would kill us in days, hunting massive beasts with nothing but wooden spears and their raw power. They weren't just another human species, they were absolute freaks of nature, the Neanderthals. So if these stories help you out, hit subscribe. Comment your location and time too. Love seeing the mix. Had someone from Helsinki and someone from Houston on the same video. One's in tomorrow, one's in yesterday, or something like that. You think you're strong. You've got nothing on them, the average. Neanderthal could crush your hand without even trying. Their bones were thicker, their muscles denser, their power beyond anything we modern humans could comprehend. And for years, we thought they were just primitive cavemen hunched over brutes that couldn't match our intelligence or adaptability. But that story was wrong, dead wrong. Recent discoveries have completely shattered everything we thought we knew about these ancient humans. Not only were they physically superior to us in almost every way, but their brains were bigger than ours. They crafted complex tools, controlled fire, created art, and survived extreme conditions that would decimate modern human populations. They weren't just surviving, they were thriving in some of the harshest environments Earth has ever produced. So, what made them such extraordinary physical specimens? And if they were so remarkable, why aren't they still here? Why did they vanish while we flourished? The answers will challenge everything you think you know about human evolution. The story of Neanderthals begins around 400,000 years ago, as a population of ancient humans became isolated in Europe during a massive glacial period. Cut off from Tsetse, other human groups in Africa, these Europeans began to evolve distinct traits that would make them perfectly suited for the brutal conditions of Ice Age Europe. Their bodies became stockier and more powerful, not because they were primitive, but because they were becoming specialized survival machines. When we look at a Neanderthal skeleton, the first thing that jumps out is the sheer robustness of their bones. Their bones were significantly thicker and denser than ours. A Neanderthal fur, that's the thigh bone, could withstand forces that would snap a modern human's leg like a twig. Their arms and legs show massive muscle attachment sites, areas where their powerful muscles connected to the bone. Scientists who study these attachment points can tell that Neanderthals had tremendously powerful biceps, triceps, and forearm muscles. But it's not just that they were stronger, their entire body was built differently. They had barrel-shaped chests that were much wider than ours, especially at the bottom of the rib cage. This expanded torso gave them larger lungs and likely a more efficient cardiovascular system, critical adaptations for high-energy activities in cold environments. Their pelvises were wider too, creating a lower center of gravity that would have made them incredibly stable and powerful. When you look at a Neanderthal skull, you immediately notice the massive brow ridge above the eyes. This wasn't just for show. That bony projection helped support their larger face and provided extra protection for their eyes. Their noses were significantly larger than ours with wider nostrils and a more pronounced bridge. This wasn't a random trait, it was a sophisticated adaptation for life in the cold. A larger nose with more internal surface area allowed them to warm and humidify the freezing air before it reached their lungs. This prevented the kind of cold damage that modern humans would suffer in similar conditions without technological help. Their facial structure also featured larger sinuses which further aided in warming inhaled air. These weren't primitive features, they were advanced adaptations that let Neanderthals thrive in environments that would kill most modern humans. Their jaws were another marvel of evolution. Neanderthals had no chin. Their jaw simply curved back from their teeth without the protruding point we have. But what they lacked in chins, they made up for in jaw strength. Their mandibles were thicker and stronger than ours, capable of generating tremendous bite force. The wear patterns on their teeth tell us they frequently used their mouths as a third hand holding animal skins or other materials while working on them. Those teeth were different too. Their incisors, the front teeth, were larger and showed distinctive wear patterns unlike anything seen in modern humans. Some researchers believe they regularly use their front teeth to grip and pull animal hides when preparing them for use, something no modern human would be able to do without quickly damaging their teeth. All these anatomical differences add up to one conclusion: Neanderthals were powerhouses, but exactly how strong were they? Scientists have used the muscle attachment sites on Neanderthal bones to estimate their strength compared to modern humans, and the results are staggering. The average Neanderthal likely had upper body strength at least 1.5 times greater than a typical modern human male. Some estimates suggest their arm strength could have been twice that of even trained modern athletes. Their grip strength would have been off the charts by our standards. A modern human male typically has a grip strength of around 80 to 120 lb of pressure. The average Neanderthal likely well over 200 boulders of crushing force in each hand. They could have easily crushed objects that would require modern humans to use tools. This extraordinary physical power wasn't just for show, it was essential for their survival strategy. Unlike later human groups who developed specialized projectile weapons that could kill from a distance, Neanderthals were close combat hunters. They crafted heavy thrusting spears designed not to be thrown, but to be driven directly into large, dangerous prey at close range. Just think about that for a moment. Neanderthals were hunting animals like woolly rhinos, cave bears, and mammoths, massive beasts that could easily kill a human, and they were doing it up close and personal. This wasn't because they couldn't conceive of better hunting methods. It was a deliberate strategy that played to their physical strengths and was perfectly adapted to the environments where they lived. The physical evidence of this high-risk hunting strategy is written in their bones. Neanderthal skeletons show patterns of injury that have been compared to those seen in modern rodeo riders. They have healed fractures distributed across their bodies, especially in the head, neck, and upper body. Exactly the pattern you'd expect from close encounters with large, dangerous animals. One study found that about 80% of Neanderthal adults showed evidence of at least one significant healed injury. The most famous example is the old man of Lepello Sa, a Neanderthal who lived to around 40 years of age, elderly by Paleolithic standards. His skeleton shows multiple healed injuries, including broken ribs, a crushed toe, knee damage, and dental abscesses. Despite these injuries, he survived for years afterward, suggesting his community cared for him during recovery. This wasn't a gentle world they lived in, and their bodies show they confronted that harshness head-on. Their strength and hunting strategy were only part of what made Neanderthals exceptional. Their bodies were also perfectly adapted to survive extreme cold in ways that went far beyond just having bigger noses. Their entire body proportion was different from ours in ways that maximized heat retention. Modern humans evolved in Africa and have body proportions suited to heat dissipation, long limbs with a high surface area to volume ratio that helps release excess heat. Neanderthals evolved the opposite body type. They had shorter limbs and stockier builds, reducing the surface area through which they could lose heat. This gave them a physique similar to modern humans who live in extremely cold environments like traditional Inuit populations, but even more pronounced. This adaptation to cold wasn't just about staying comfortable, it was about survival when temperatures plunged. During glacial periods, the Neanderthals' compact muscular bodies would have been significantly more efficient at retaining heat than the bodies of modern humans. This meant they could survive with less technological assistance, fewer layers of clothing, less fuel needed for fires, and less food required to maintain body temperature. Speaking of food, Neanderthals needed a lot of it. Their powerful muscles, larger brains, and the cold environments they inhabited all required tremendous caloric intake. Scientists estimate that Neanderthals would have needed anywhere from 3,500 to 5,000 calories daily, roughly twice what a sedentary modern human consumes and comparable to what Olympic athletes eat during training. Where did all these calories come from? Primarily, they came from meat. Isotopy analysis of Neanderthal bones shows they were top-level carnivores, getting most of their protein from large herbivores like deer, bison, wild horses, and even woolly rhinoceros and mammoths. In many locations, they appear to have specialized in hunting reindeer during seasonal migrations, intercepting the herds at strategic points in the landscape. This doesn't mean they never ate plants. Recent studies of dental plaque from Neanderthal teeth have revealed evidence of various plant foods, including grains, tubers, and even medicinal plants. But the overall picture that emerges is of a diet heavily dominated by meat, especially in northern regions during colder periods when plant foods would have been scarce. This meat-heavy diet wasn't just a choice, it was a necessity dictated by their environment and metabolism. The bitter cold of glacial Europe meant plant foods were seasonal and limited. High-energy animal products, not just muscle meat, but fat, marrow, and organ meats provided the concentrated calories Neanderthals needed to power their robust bodies through harsh winters. How they got all this meat is a testament to their extraordinary physical capabilities and hunting prowess. The archaeological evidence from Neanderthal sites shows they were skilled and strategic hunters who could take down the largest and most dangerous prey animals of Ice Age Europe. At sites across Europe, archaeologists have found the butchered remains of everything from reindeer and wild horses to woolly rhinoceros and even young mammoths. The distribution of cut marks on these bones shows the Neanderthals weren't just scavenging. They were systematically breaking down complete carcasses, extracting not just meat, but valuable fat, marrow, and other nutrients. In some locations, like the site of Haute in France, evidence suggests Neanderthals engaged in mass killings, bison driving herds into natural traps where they could be efficiently slaughtered. At La Côte de Saint-Brieuc in Jersey, an island in the English Channel, archaeologists found evidence that Neanderthals may have driven mammoth herds off cliffs as a hunting strategy. But these were not simple opportunistic hunters. The evidence shows they understood animal behavior and planned their hunts carefully. At many sites, the remains show a focus on prime-aged adult animals, the most dangerous, but also the most nutritious targets. This selective hunting strategy required not just physical power, but sophisticated knowledge and planning. Their hunting technology, while not as diverse as that of later humans, was remarkably effective for their needs. Wooden spears found at Schöningen in Germany, dating to around 300,000 years ago, show these weren't crude sticks but carefully crafted weapons. The spears were made from spruce wood with the weight perfectly balanced toward the front, similar to modern javelins. The tips were hardened by careful charring, creating weapons that could penetrate the thick hides of large animals. More surprising to many researchers was the discovery that Neanderthals sometimes used ranged weapons at the site of Abri-Dumara. In France, microscopic analysis of stone points showed impact damage and traces of binding materials that suggest they were used as projectile tips, possibly for thrown spears. While not as advanced as the bows and atolls of later humans, these findings show Neanderthals weren't limited to close-quarters combat. Perhaps most impressive was their mastery of adhesive technology. At multiple sites across Europe, researchers have found evidence that Neanderthals created complex adhesives using birch bark tar, a process that requires carefully controlled heating to extract the sticky resin without burning it. They used these adhesives to attach stone points to wooden shafts, creating more effective composite tools. The process of creating birch bark tar is so complex that some archaeologists have attempted to recreate it using only technologies available to Neanderthals, with limited success. The physical demands of the Neanderthal lifestyle left their mark on their skeletons in another way. Asymmetry. Studies of Neanderthal arm bones show they typically had significantly stronger right arms than left, a pattern consistent with repeatedly performing powerful right-handed thrusting motions. This fits perfectly with what we know about their hunting techniques and provides further evidence that their extraordinary strength wasn't just genetic. It was developed through a lifetime of intense physical activity. We shouldn't think of Neanderthals as simply stronger versions of ourselves. Their entire physiology was different, adapted to meet the demands of their lifestyle and environment. Their muscle fiber composition likely differed from ours, with a higher proportion of fast twitch fibers that generate explosive power rather than endurance. Their metabolic rates were higher, their cardiovascular systems more efficient at delivering oxygen during intense activity, and their bodies better at conserving heat in frigid conditions. These weren't primitive traits, they were specialized adaptations that made Neanderthals incredibly successful in their ecological niche. For over 300,000 years, they thrived in environments ranging from the Mediterranean to the edge of the Arctic, surviving multiple glacial cycles and rapid climate shifts that would have challenged even technologically equipped modern humans. But their physical prowess wasn't the only remarkable thing about them. Perhaps the most surprising aspect of Neanderthal biology, and the one that has forced scientists to completely reconsider our view of these ancient humans, was their brains. For decades, the scientific consensus held that Neanderthals were intellectually inferior to modern humans. Their distinctive skull shape with its elongated form and pronounced brow ridge was taken as evidence of primitive cognitive abilities. But as more complete Neanderthal skulls were discovered and analyzed, a surprising fact emerged. Their brains were actually larger than ours. The average Neanderthal brain volume was around 1,600 cm, compared to about 1,400 cm for modern humans. Some Neanderthal specimens had brains as large as 1,740 cm, well beyond the size of even the largest modern human brains. Brain size isn't everything. Of course, the internal organization matters too, but here again, detailed studies of Neanderthal skull endocasts. Models of the brain based on the internal shape of the skull have revealed surprising sophistication. While their brains were organized somewhat differently than ours, with relatively larger areas devoted to vision and body control, they still had well-developed frontal lobes, the areas associated with planning, decision-making, and social cognition. The implications are clear. Neanderthals weren't cognitively inferior to modern humans, they were just different. Their brains were adapted for the specific challenges of their lifestyle and environment, with enhanced capabilities in areas like spatial awareness, visual processing, and motor control, all critical for hunters navigating complex terrain and engaging dangerous prey at close quarters. This neural difference extended to their sensory capabilities as well. Studies of Neanderthal skulls suggest they had larger eye sockets than modern humans, potentially indicating larger eyes and enhanced visual capabilities, particularly in low-light conditions. This would have been a significant advantage for hunters in the forests of Europe, especially during the long winters when daylight was limited. Their sense of smell was likely different too. The structure of the Neanderthal nasal cavity suggests they may have had a more acute sense of smell than modern humans. Another advantage for hunters who needed to track prey and detect potential dangers in their environment. Even their hearing may have been adapted to their lifestyle. Studies of Neanderthal ear bones suggest they may have had different auditory capabilities than modern humans, potentially with enhanced sensitivity to certain frequency ranges that would have been useful for detecting prey or communicating in forested environments. All these sensory adaptations paint a picture not of primitive brutes, but of highly specialized humans whose entire biology was exquisitely adapted to the demands of life. As Ice Age hunters in European forests and steppes, and the evidence for their cognitive sophistication goes far beyond just their brain size. The archaeological record shows Neanderthals engaged in behaviors that were once thought to be exclusive to modern humans, behaviors that require abstract thinking, planning, and cultural transmission. They controlled fire not just for warmth, but for cooking, transforming tough, fibrous foods into more digestible forms and potentially unlocking more calories from their diet. They crafted complex tools that required multiple steps to produce, including composite tools that combined different materials. They cared for their injured and elderly, as shown by numerous skeletons with healed injuries that would have required long-term care to survive. Most surprisingly to many researchers, they created art and symbolic objects. At sites across Europe, archaeologists have found evidence of Neanderthal artistic expression, pigments processed for use as colorants, shell beads apparently used as ornaments, and even cave paintings that predate the arrival of modern humans in Europe. At Brunel Cave in France, archaeologists discovered something truly extraordinary: a circular structure made from broken stalagmites located deep within the cave where no natural light could reach. Dated to 176,000 years ago, when only Neanderthals inhabited Europe. This structure suggests they were venturing deep into caves, controlling fire for illumination, and creating organized structures for purposes we can only guess at. Perhaps ritual, perhaps social. These weren't the actions of simple brutes. They were the behaviors of complex, intelligent beings with rich social lives and cultural traditions, and they force us to completely reconsider our understanding of who the Neanderthals were. So if Neanderthals were so physically powerful, so well adapted to their environment, and so cognitively sophisticated, why did they disappear? Why did our ancestors with their more fragile bodies and similar brain sizes survive while the mighty Neanderthals vanished? The answer isn't simple, and scientists are still debating the exact causes of Neanderthal extinction, but several factors likely contributed to their demise. One key factor was climate change. Around 40,000 years ago, Europe experienced a series of rapid, extreme climate fluctuations known as Heinrich events. These sudden cold snaps would have dramatically altered the ecosystems Neanderthals relied on, potentially reducing the populations of their preferred prey species and making their high-calorie meat-heavy diet harder to sustain. Another factor was the arrival of modern humans in Europe. Beginning around 45,000 years ago, these newcomers brought different technologies, different hunting strategies, and possibly different social structures that may have given them competitive advantages in certain environments. There's little evidence for direct violence between Neanderthals and modern humans. No mass graves or skeletons with weapon injuries that would suggest warfare or genocide. But competition for resources, even peaceful competition, could have slowly pushed Neanderthal populations into decline. Disease may have played a role too. Modern humans migrating from Africa likely carried pathogens that Neanderthals had never been exposed to and had no immunity against. These novel diseases could have devastated Neanderthal populations already stressed by climate change and competition. Perhaps most intriguingly, we now know that Neanderthals didn't completely disappear. Genetic studies of modern human populations outside of Africa reveal that most of us carry between 1 and 4% Neanderthal DNA in our genomes. Clear evidence that our ancestors didn't just compete with Neanderthals, they interbred with them. This interbreeding suggests that rather than being replaced entirely, Neanderthals may have been partially absorbed into the expanding modern human population as their numbers dwindled due to climate change and competition. The remaining Neanderthals may have increasingly joined modern human groups, their distinctive genetic lineage gradually becoming diluted but never completely lost. The story of the Neanderthals is not therefore simply one of failure and extinction. It's a complex tale of adaptation, resilience, and ultimately transformation. Their physical power and specialized adaptations made them extraordinarily successful for hundreds of thousands of years, far longer than our species has existed, and elements of their biology live on in many of us today. The Neanderthals weren't failed humans or evolutionary dead ends. They were remarkable beings whose physical capabilities and adaptations allowed them to thrive in some of the harshest environments on Earth. Their story reminds us that there are many ways to be human, many paths that our evolution might have taken. As we've seen, Neanderthals were true physical freaks of nature. Their bones were stronger, their muscles more powerful, their bodies more resilient to cold and injury than ours could ever be. They were specialized survival machines perfectly adapted to the demands of Ice Age Europe. But their story is far from complete. As new discoveries are made and new analytical techniques developed, our understanding of these remarkable humans continues to evolve. And as we'll see in the next part of our exploration, their physical prowess was matched by cognitive and technological abilities that force us to completely reconsider who they were and how they lived. The evidence is clear. Neanderthals weren't primitive brutes. They were sophisticated, powerful humans whose biology and culture were perfectly adapted to survive and thrive in the challenging environments of Ice Age Europe. Their extraordinary physical strength was just one aspect of a complex and successful adaptation that allowed them to dominate Europe for hundreds of thousands of years. In the next part of our exploration, we'll delve deeper into the Neanderthal mind, their cognitive abilities, their technological innovations, and the evidence for complex social and cultural behaviors that paint a picture far different from the stereotypical grunting cavemen of popular imagination. And we'll discover that, in many ways, they weren't so different from us after all. We've established that Neanderthals were physical powerhouses, stronger, more robust, and perfectly adapted to survive in frigid environments that would kill most modern humans within days. But their extraordinary nature goes far beyond just brute strength. Their brains and cognitive abilities challenge everything we thought we knew about these ancient humans. For decades, the scientific narrative portrayed Neanderthals as intellectually inferior to modern humans. Bigger and stronger, yes, but lacking the mental sophistication that supposedly allowed Homo sapiens to compete them. This convenient story positioned our ancestors as the rightful inheritors of the planet, destined to replace their more primitive cousins through superior intelligence. But recent discoveries have completely demolished this self-serving myth. Neanderthals weren't just muscular brutes. They were sophisticated beings with large brains, complex technology, and social structures that allowed them to thrive for hundreds of thousands of years in environments we can barely survive in with all our modern technology. Let's start with the most surprising fact. Neanderthals had bigger brains than we do. The average Neanderthal brain volume was approximately 1/600 cubic cm, compared to about 1/400 cubic cm for modern humans. Some Neanderthal specimens had brains as large as 1/700 cubic cm, well beyond the range of even the largest modern human brains. Size isn't everything when it comes to brains, of course. The internal organization matters tremendously. And here's where things get really interesting. Detailed studies of Neanderthal skull endocasts, models of the brain based on the internal shape of the skull, reveal that their brains were organized differently than ours, but not in the way you might expect. Neanderthals had proportionally larger visual cortices, the parts of the brain responsible for processing visual information. This enhanced visual processing capacity would have been tremendously advantageous for hunters operating in the varied landscapes of Ice Age Europe, allowing them to spot prey at greater distances and in lower light conditions than modern humans could manage. They also devoted more neural resources to body control and somatosensory processing, the parts of the brain that govern movement and physical sensation. This makes perfect sense given their highly physical lifestyle and hunting techniques that required precise control of powerful movements. What's fascinating is that when researchers account for these differences in brain organization, they find that the remaining higher cognitive areas of the Neanderthal brain were comparable in size to those of modern humans. Their frontal lobes, the parts of the brain associated with planning, decisioning, and social cognition, were well developed, suggesting cognitive capabilities similar to our own. But the most compelling evidence for Neanderthal cognitive sophistication comes not from their brain anatomy but from what they actually did, the archaeological record of their behaviors and technologies. And this evidence is forcing scientists to completely reconsider who these ancient humans were. Humans consider their technological achievements. For over 150 years, the Mustisterian stone tool industry, the distinctive tool-making tradition associated with Neanderthals, was considered relatively simple and static compared to the rapidly evolving technologies of early modern humans. But closer examination reveals a level of sophistication that demands respect. Neanderthals were masters of what called the Lavoie technique, a method of stone tool production that requires careful planning and precise execution. The technique involves preparing a stone core in a specific way to control the shape and size of the resulting flakes, creating tools with predetermined forms perfectly suited for specific tasks. This isn't simple banging rocks together. It requires abstract thinking, the ability to visualize the finished tool within the raw stone, and precise motor control to execute the necessary strikes. Modern experimental archaeologists who attempt to recreate these tools often require years of practice to achieve the level of skill evident in even average Neanderthal tools. And their technological prowess went far beyond just knapping stone. At multiple sites across Europe, archaeologists have found evidence that Neanderthals created and used complex adhesives to attach stone points to wooden shafts, creating more effective composite tools. The most common adhesive was birch bark tar, a substance that requires a sophisticated multi-stage production process. To create birch bark tar, Neanderthals had to carefully heat birch bark in a low oxygen environment at controlled temperatures. Too cool and the tar won't form, too hot and it will simply burn. This process requires not just fire control, but an understanding of pyrotechnology that was once thought to be exclusive to modern humans. The complexity of this process is so great that modern archaeologists have struggled to recreate it using only technologies available to Neanderthals. The fact that Neanderthals routinely produced these adhesives across Europe for tens of thousands of years speaks volumes about their cognitive capabilities and technological know-how. Their mastery of fire extends beyond just adhesive production. Evidence from Neanderthal sites shows they strategically placed hearths within their living spaces, controlled fire temperatures for different purposes, and likely used fire not just for warmth, but for cooking, hardening wooden tools, and possibly even for ritual purposes. At the site of Abric Romain in Spain, archaeologists found evidence of multiple hearths arranged in what appears to be a purposeful layout within a living space, suggesting Neanderthals were organizing their living environments in complex ways. The hearths were positioned to create different activity areas, some for tool-making, others for food processing, others perhaps for sleeping. Their toolkit wasn't limited to stone and wood either. At several sites, archaeologists have found evidence of bone tools, implements crafted from animal bones that were shaped and polished for specific purposes at Abri and Pech de Laz in France. Researchers discovered Neanderthal bone tools called liso, specialized implements used to work animal hides, making them more supple and water-resistant. What's remarkable about these tools is that they represent the first documented instance of a technology that would later become common among modern humans. This isn't a case of Neanderthals copying modern human technology. These bone tools predate the arrival of modern humans in the region by thousands of years. It's a clear case of independent invention, further evidence of Neanderthal cognitive sophistication and technological innovation. Even more surprising was the discovery in 2020 of direct evidence of fiber technology used by Neanderthals. At the site of a breed in France, researchers found a 3-ply cord fragment made from inner bark fibers dating to between 41 and 52,000 years ago, the oldest direct evidence of string or cord making ever discovered. The significance of this find can't be overstated. Creating twisted fiber cordage requires understanding of multiple concepts: how materials can be processed to extract usable fibers, how those fibers can be twisted to create stronger strands, and how those strands can be combined to create even stronger cord. It implies a mathematical understanding of patterns and processes that was once thought to be uniquely human. And cordage isn't just significant as a technology in itself, it's the foundation for numerous other technologies: ropes, nets, bags, clothing, shelter components, all depend on the ability to create and use cordage. The presence of this technology suggests Neanderthals may have had access to a whole range of complex tools and equipment that simply haven't preserved in the archaeological record. We've long known that Neanderthals were expert hunters, but recent research has revealed just how sophisticated their hunting strategies were. Far from being simple, opportunistic predators, Neanderthals employed complex, planned hunting tactics that required intimate knowledge of animal behavior and landscape features. At sites across Europe, the evidence shows Neanderthals strategically positioned themselves to intercept migrating herds at natural bottlenecks in the landscape, places where the terrain would concentrate animals and make them more vulnerable. They appear to have coordinated group hunts with different individuals playing different roles in the pursuit and takedown of dangerous prey. Some sites suggest they employed drive hunting techniques where groups of hunters would work together to channel animals toward ambush points or natural traps like ravines or swampy areas. This kind of coordinated hunting requires not just physical prowess, but communication, planning, and shared knowledge of both the terrain and the behavior of prey species. The sophistication of their hunting is reflected in their prey selection. Studies of animal remains from Neanderthal sites show they weren't just taking whatever animals they happened to encounter. They were selectively targeting prime-aged adult animals, theonies in their physical prime, that would provide the most nutritional benefit despite being the most dangerous to hunt. This kind of selective hunting isn't the behavior of simple-minded brutes. It reflects complex decision-making that weighs risks against benefits and requires extensive knowledge passed down through generations. It's the behavior of sophisticated hunter-gatherers with rich cultural traditions and deep ecological understanding. Their ecological knowledge extended beyond just hunting. Analysis of plant remains and residues from Neanderthal sites shows they exploited a wide range of plant resources for food, medicine, and materials. They weren't just meat eaters, they were knowledgeable foragers who understood which plants were edible, which had medicinal properties, and which could be used for technological purposes. At the site of Shanidar Cave in Iraq, scientists found pollen, concentrations around a Neanderthal burial that suggest flowers may have been placed with the body. While the flower burial interpretation has been debated, the presence of these plant remains demonstrates that Neanderthals were interacting with plants in complex ways beyond just basic subsistence. More compelling is the evidence from dental calculus, the hardened plaque on Neanderthal teeth. Analysis of this material has revealed traces of numerous plant species, including some with medicinal properties. One particularly striking example comes from El Tidron Cave in Spain, where researchers found evidence that a Neanderthal with a dental abscess appears to have been consuming plants with antibiotic properties, suggesting they understood not just which plants were edible, but which could be used to treat specific ailments. This kind of sophisticated ethnobotanical knowledge, understanding which plants can be used for which purposes, requires not just individual learning, but cultural transmission across generations. It's yet another line of evidence pointing to complex Neanderthal societies with accumulated knowledge and traditions. Perhaps the most surprising and controversial aspect of Neanderthal behavior is their apparent capacity for symbolic expression. Art, ornaments, and potentially ritual practices that were once thought to be exclusively human traits. For decades, the scientific consensus held that symbolic behavior emerged suddenly with modern humans, representing a cognitive leap that separated us from all other hominins. But evidence from Neanderthal sites is challenging this narrative. At multiple sites across Europe, archaeologists have found evidence that Neanderthals collected and processed colored pigments like red and yellow ochre. These materials had no obvious practical use, but may have been used for body decoration, coloring, animal hides, or creating visual symbols. At Cueva de los Ion in Spain, researchers found perforated seashells stained with pigments that appear to have been worn as ornaments dating to over 115,000 years ago, long before modern humans arrived in the region. Similar finds from other sites suggest this wasn't an isolated occurrence but a widespread Neanderthal practice. Even more astonishing is the evidence for Neanderthal cave art at La Paca Cave in Spain. A ladylike symbol painted in red ochre has been dated to more than 164,000 years ago, at least 20,000 years before modern humans arrived in Europe. Similar dates have been obtained for hand stencils at Maltra Viezo Cave and a red geometric symbol at Ardal's Cave, both in Spain. If these dates are accurate, and they remain controversial among some researchers, they provide clear evidence that Neanderthals were creating symbolic representations long before they encountered modern humans. This would be a dramatic reputation of Theidea that symbolic thought was unique to Homo sapien. Less controversial, but equally significant, is the evidence for Neanderthal constructions deep within cave systems. At Bruniquel Cave in France, archaeologists discovered a circular structure made from deliberately broken stalagmites located more than 300 meters from the cave entrance in complete darkness. This structure has been dated to 176,000 years ago, when only Neanderthals inhabited Europe. The implications are profound. Creating this structure would have required not just planning and cooperation, but artificial light. Neanderthals would have had to maintain and control fire as they ventured deep into the cave, and the purpose of the structure remains mysterious. It shows no evidence of habitation or practical use, suggesting it may have had ritual or symbolic significance. These aren't the actions of simple instinct-driven brutes. They're the behaviors of beings with complex inner lives, beings capable of abstract thought, symbolic representation, and potentially spiritual or ritualistic practices. Perhaps the most humanizing aspect of Neanderthal behavior is their apparent care for one another. Multiple Neanderthal skeletons have been found with evidence of serious injuries and disabilities that had healed before death, individuals who could only have survived with the support and care of their community. The famous old man off La Chapelle is a classic example. This elderly Neanderthal had severe arthritis, a damaged hip, missing teeth, and other pathologies that would have made it difficult for him to contribute to hunting or other physically demanding tasks. Yet, he survived to an age that was advanced by Paleolithic standards, suggesting his community continued to care for him despite his limited productivity. Similar cases have been found at other sites, individuals with serious injuries or congenital deformities who survived for years after becoming disabled. This isn't the behavior of creatures concerned only with immediate survival. It's evidence of social bonds, compassion, and a recognition of the value of individuals beyond their immediate utility, quintessentially human traits. And then there are the burials. At multiple sites across Europe and the Middle East, archaeologists have found Neanderthal remains in positions and contexts that strongly suggest intentional burial. The bodies were placed in natural or artificially created depressions, sometimes in flexed positions, and occasionally with what appeared to be grave goods, objects placed with the deceased. At Shanidar Cave in Iraq, several Neanderthal burials have been discovered, including the famous flower burial mentioned earlier. While the interpretation of flowers being deliberately placed with the body remains controversial, the deliberate burial itself is not in doubt. More recent excavations at La Chapelle-Sun in France have strengthened the case for Neanderthal burials. Careful re-examination of the site has revealed clear evidence of a deliberately dug pit in which the body was placed, not simply a natural depression, as some skeptics had suggested. Intentional burial of the dead implies not just practical concerns about hygiene or predators, but conceptual thinking about death, possibly beliefs about an afterlife, and certainly emotional attachments to deceased community members. It's one of the clearest indicators that Neanderthals possessed a mental and emotional life comparable to our own. All of this evidence, from their technology to their art, from their ecological knowledge to their care for the injured, paints a picture of Neanderthals as sophisticated beings with rich cultural traditions and complex social lives. They weren't lesser versions of us. They were a different expression of humanity, adapted to different circumstances, but no less intelligent or capable. So, if they were so capable, why did they disappear while our ancestors thrived? The answer is complex and still debated, but it likely involves a combination of factors rather than any single decisive advantage possessed by modern humans. Climate change clearly played a role. Around 40,000 years ago, Europe experienced a series of rapid, severe climate fluctuations, sudden cold snaps followed by brief warming periods. These dramatic shifts would have stressed the ecosystems Neanderthals relied on, potentially reducing prey populations and making their high-calorie meat-dependent diet more difficult to maintain. Modern humans, with their slightly different technological toolkit and potentially more flexible subsistence strategies, may have been better equipped to weather these changes. Evidence suggests early modern humans exploited a broader range of food resources, including small game and aquatic foods that appear less frequently in Neanderthal sites. But it wasn't just about technology or subsistence. Demographic factors likely played a crucial role. Genetic studies of Neanderthal remains suggest they maintained relatively small, isolated populations with limited genetic diversity. This would have made them vulnerable to inbreeding depression, reduced fitness due to the accumulation of harmful genetic variants. Modern humans, in contrast, appear to have maintained larger, more connected population networks with more genetic mixing between groups. This demographic structure would have provided greater resilience in the face of environmental challenges and potential competitive advantages in resource-rich areas. Disease may have been another factor. Modern humans migrating from Africa would have carried pathogens that Neanderthals had never been exposed to and had no immunity against. These novel diseases could have had devastating effects on Neanderthal populations already stressed by climate change, competition. And competition, while perhaps not taking the form of direct violence, was likely significant. As modern human populations expanded into Europe, they would have increasingly competed with Neanderthals for key resources, prime hunting territories, sheltered cave sites, high-quality stone for tools. Even without conflict, this competition could have slowly pushed Neanderthal populations into decline. But perhaps the most intriguing aspect of the Neanderthal disappearance is that they didn't completely vanish. Genetic studies have revealed that most people of Eurasian descent carry between 1 and 4% Neanderthal DNA in their genomes. Clear evidence that our ancestors didn't just compete with Neanderthals, they interbred with them. This interbreeding suggests that rather than being completely replaced, Neanderthals may have been partially absorbed into the expanding modern human population. As their numbers dwindled due to the factors discussed above, the remaining Neanderthals may have increasingly joined modern human groups, their distinctive genetic lineage gradually becoming diluted but never completely lost. The genetic legacy of these interbreeding events remains with us today. Some Neanderthal gene variants appear to have been advantageous for modern humans moving into the colder environments of Eurasia. Genes involved in skin and hair characteristics, fat metabolism, and immune responses to European pathogens. These beneficial variants were retained by natural selection and remain part of our genetic makeup. Other Neanderthal variants were apparently detrimental and were gradually purged from the human genome. These include genes on the X chromosome suggesting male hybrid offspring may have had reduced fertility and genus involved in certain aspects of brain development. This selective retention and elimination of Neanderthal DNA has shaped the human genome in complex ways that we're only beginning to understand. So the story of the Neanderthals isn't simply one of inferior beings replaced by superior ones. It's a complex tale of two human species, both highly intelligent, both capable of remarkable technological and cultural achievements, facing the challenges of a rapidly changing world with different biological and cultural adaptations. The Neanderthals weren't failed humans or evolutionary dead ends. They were remarkably successful beings who thrived in some of the most challenging environments on Earth for hundreds of thousands of years, far longer than our species has existed. Their physical and cognitive adaptations allowed them to dominate Ice Age Europe in ways we can barely imagine. And elements of their biology live on in many of us today. As we continue to discover more about these extraordinary beings, our appreciation for their capabilities only grows. The crude caricatures of hunched, grunting brutes that once dominated popular culture have given way to a much more nuanced and respectful understanding of who the Neanderthals really were. They weren't just freaks of nature in terms of their physical strength. They were sophisticated, intelligent beings with rich cultural traditions, complex technologies, and social lives not so different from our own. Their story isn't a sidebar in human evolution. It's a parallel narrative of a different but equally valid way of being human. And as we'll explore in the next part of our journey, the Neanderthals' remarkable adaptations extended far beyond their bodies and brains to encompass complex social structures and cultural innovations that allowed them to thrive in environments we can barely survive in today. Their story continues to unfold as new discoveries reveal more about these extraordinary humans who walked alongside our ancestors through the Ice Age landscapes of ancient Europe. We've explored the extraordinary physical prowess of Neanderthals, their immense strength, cold-adapted bodies, and specialized hunting capabilities. We've examined their remarkable brains and cognitive abilities, larger than our own, organized differently, but clearly capable of sophisticated thought and innovation. Now let's delve even deeper into what truly made Neanderthals such remarkable beings, their social structures, survival strategies, and the astonishing technologies they developed to thrive in the harshest environments Earth has ever produced. Imagine yourself transported back 40,000 years to the depths of the last ice age in Europe. You're standing on a windswept plain in what will someday become southern France. The temperature hovers around -20 degrees C. The wind cuts like a knife. The landscape is a treeless steppe, stretching to the horizon, broken only by the occasional rocky outcrop. There are no buildings, no roads, no power lines. Nothing of the modern world exists. Just you, the cold and the unforgiving wilderness. Without modern technology, without Gore-Tex jackets, insulated boots, GPS devices and emergency services, how long would you survive? Hours, perhaps a day or two at most. This was the world of the Neanderthals. Not just for a weekend camping trip or a survival challenge, but for their entire lives, generation after generation, for hundreds of thousands of years. And they didn't just survive in these conditions, they thrived, they hunted, they raised families, they created art and technology. They lived full, complex lives in environments that would kill most modern humans within days. How did they do it? The answer lies not just in their physical adaptations, though those were certainly crucial, but in their social structures, their accumulated knowledge, and the sophisticated technologies they developed. Technologies that have only recently begun to receive the recognition they deserve. Let's start with their living spaces. The popular image of Neanderthals as cave dwellers isn't entirely wrong. They did frequently use caves and rock shelters as bases, especially in colder regions and during winter months, but archaeological evidence shows they were far more sophisticated in their use of these spaces than previously thought. At CITES Cross, Europe, archaeologists have found evidence of structured living areas within caves, spaces organized for different activities with hearths strategically placed for warmth, cooking, and light. At a brick Romani in Spain, researchers discovered the remains of wooden platforms that appear to have been used as sleeping areas raised off the cold, damp cave floor. These weren't just random nests, they were deliberately constructed fixtures within a well-organized living space. But Neanderthals weren't confined to caves. At open-air sites like Molova in Ukraine, archaeologists have found evidence of constructed dwellings. Structures built using mammoth bones as foundations and supports likely covered with hides to create sheltered living spaces. Even in areas without natural caves, these structures weren't temporary overnight shelters. They show evidence of repeated use and maintenance over time. What's particularly impressive about these living spaces is the evidence they provide for long-term planning and resource management. Neanderthals weren't just reacting to immediate needs, they were anticipating future requirements and preparing accordingly. They stockpiled materials for fires, gathered tools and resources, and created spaces that could support extended periods of occupation during the harshest seasons. This kind of foresight extends to their food acquisition strategies as well. Far from being opportunistic scavengers or simple hunters, taking whatever prey they happened to encounter, Neanderthals employed sophisticated strategies that required intimate knowledge of animal behavior and landscape features. Studies of animal remains from Neanderthal sites reveal patterns that speak to highly organized hunting practices. At many sites, the bones show a focus on specific prey species during particular seasons. Reindeer during autumn migrations, ibex during summer months when they descended to lower elevations, bison when they congregated in valleys during winter. This selective hunting required not just tracking skills, but an understanding of animal migration, patterns, and seasonal behaviors. The evidence also shows they were transporting specific parts of animals back to their living sites, the most nutritionally valuable portions that provided the highest return for the energy expended in carrying them. This kind of selective transport isn't random or instinctive. It reflects calculated decisions about resource efficiency, another sign of sophisticated planning and knowledge. Perhaps most impressive is the evidence for communal hunting techniques. At sites like La Côte de Saint Bride in Jersey, an island in the English Channel, archaeologists found the remains of dozens of mammoths and rhinoceroses at the base of a cliff. The pattern of these remains suggests Neanderthals were driving herds toward the cliff edge, causing them to fall to their deaths, a hunting technique that would have required coordination among multiple individuals playing different roles. Similar evidence for cooperative hunting has been found at sites across Europe. These weren't solitary hunters, but coordinated groups working together to take down prey that no individual could handle alone. This kind of cooperation required communication, planning, and social bonds, all hallmarks of complex social structures, and these social structures extended beyond just hunting parties. Multiple lines of evidence suggest Neanderthals lived in small, close-knit groups with strong social bonds and mutual support systems. The care for injured individuals discussed earlier, those who survived serious injuries that would have prevented them from contributing to hunting or other physically demanding tasks, demonstrates social commitments that transcended immediate utility. The size of these groups has been estimated based on the dimensions of living spaces and resource availability in different environments. In most regions, Neanderthals appear to have lived in bands of perhaps 10 to 20 individuals, extended family groups that stayed together year-round, sharing resources and knowledge. These bands weren't completely isolated, however. The distribution of distinctive stone tools and raw materials suggests networks of interaction between different Neanderthal groups across substantial distances. High-quality stone was sometimes transported or traded over distances of 50 kilometers or more, indicating contact and exchange between different bands. Within these groups, there's evidence for division of labor and specialized roles. Patterns of wear and injury on Neanderthal skeletons suggest some individuals consistently performed certain tasks. Some focused more on hunting, others perhaps on processing hides or creating tools. This kind of specialization allows groups to accomplish more than if everyone were a generalist, and it's another indicator of social complexity. There's even tantalizing evidence for distinct cultural traditions among different Neanderthal groups, regional variations in tool-making techniques, resource exploitation strategies, and possibly symbolic practices. These weren't just instinctive behaviors shared by all members of the species, but learned traditions passed down through generations within specific communities. This cultural transmission, the passing of knowledge from one generation to the next, is perhaps one of the most distinctively human aspects of Neanderthal life. The complexity of their technologies and hunting strategies couldn't have been reinvented by each individual or even each generation. They represent accumulated knowledge built up over thousands of years and preserved through teaching and learning within social groups. Consider their technological achievements. The sophistication of Neanderthal stone tools has long been recognized, but recent research has revealed they were capable of much more than just knapping flint. They created composite tools, implements combining different materials like stone, wood, and adhesives to create more effective weapons and tools than could be made from any single material. The production of birch bark tar adhesive mentioned earlier is particularly impressive. Creating this substance requires a complex multi-stage process involving the careful application of heat in a low-oxygen environment. The tar must then be processed and applied while still warm to cool, and it becomes brittle and unusable. This technology requires not just knowledge of materials but precise control of temperature and timing. Experimental archaeologists have attempted to recreate this process using only technologies available to Neanderthals with limited success. The fact that Neanderthals routinely produced these adhesives across Europe for tens of thousands of years speaks volumes about their technological sophistication and the depth of their cultural knowledge. They weren't just making tools, they were engaging in complex manufacturing processes that required planning, precision, and specialized knowledge. This isn't the behavior of simple brutes acting on instinct. It's the work of intelligent beings with rich cultural traditions and accumulated technical expertise. Their technological prowess extended to fibers and cordage as well. The discovery of a 3-ply cord fragment at Abri-du-Marais in France mentioned earlier indicates they understood how to process plant materials to extract usable fibers, how to twist those fibers to create stronger strands, and how to combine those strands to create even more robust cord. This might seem like a simple technology to modernize, but it represents a fundamental innovation that underlies countless other technologies. Cordage is the foundation for nets, bags, snares, fishing lines, and components of complex tools like bows. It's a transformative technology that vastly expands what humans can accomplish, and Neanderthals mastered it tens of thousands of years ago. The evidence for fiber technology raises intriguing questions about what other perishable technologies Neanderthals might have developed. Did they create basketry, woven mats, nets for fishing or trapping small game? The cordage fragment suggests these possibilities, though direct evidence is scarce due to the poor preservation of organic materials in most archaeological contexts. We do know they processed animal hides to create what were likely clothing and shelter components. At multiple Neanderthal sites, archaeologists have found specialized tools used for scraping and softening hides, indicating not just the use of animal skins for practical purposes, but a sophisticated understanding of how to transform raw hides into more useful materials. The bone tools discovered at Abri-Perroni and Pêche de Laz in France. The liso ore smoothers used for working hides represent another level of technological refinement. These weren't simply stones picked up and used opportunistically, but carefully crafted implements designed for specific tasks. Their creation required selecting appropriate bones, shaping them to the desired form, and polishing them to create the smooth working surface necessary for effectively processing hides. This kind of specialized tool creation suggests not just technical knowledge, but specialized roles within Neanderthal societies, individuals who developed particular skills and perhaps focused on specific tasks. It's another indicator of social complexity and division of labor within their communities. Fire technology was another area where Neanderthals demonstrated remarkable sophistication. They weren't just using naturally occurring fires started by lightning strikes. They were creating and controlling fire for multiple purposes. Hearths found at Neanderthal sites show evidence of repeated use and maintenance with different areas, seemingly designated for different fire-related activities. They appear to have used fire not just for warmth and cooking, but for hardening wooden tools, processing birch bark tar, and potentially for ritual or social